here's the second equation. Again, we're solving for theta. We're looking for the angles that when you put them into this equation, it will be true. And theta is going to be between 0 and 360 degrees. When we're solving, we can't get theta by itself right away. So what we have to do is we have to solve for the trig function that involves theta. And this is kind of nice because it's already in terms of one function. We don't have tangent and sine, or secant and cosine. It's already in terms of tangent. So if you think about it, think of it as like 3x squared minus 1 equals 0, where the tangent of x, that is equal to, or excuse me, the tangent of theta, that is equal to x. And so it becomes a problem like this one. Solving, well, first step, we add 1 to both sides. We're solving for x. We get x squared equals 1/3. And then we take the square root of both sides, and we get plus or minus the square root of 1/3. And then we rationalize, and x equals plus or minus the square root of 3 over 3. And again, I didn't do anything that would cause extraneous roots, so this would be my solution. That's if it were an algebraic equation. Since we have a trigonometric equation, we're going to apply those rules, those algebraic rules, to solving this problem. First of all, think of it like this. Remember that tangent squared theta is the same as the tangent of theta quantity squared. Our goal in the end is to get tangent of theta and find what it's equal to. So, first of all, we need to try to isolate this. Well, this term, 3 tangent squared theta, needs to be on one side. Everything else needs to come to the other side because it doesn't involve tangent of theta. Again, we're trying to solve for tangent of theta. Next, we go ahead and divide both sides by 3, because I do not want a coefficient of 3, I'd like a coefficient of 1. So we have tangent squared theta equals 1/3. Getting close. I want not tangent squared theta, but tangent of theta. So what we're going to do is we're going to take the square root of both sides. And we have the tangent of theta, and that equals plus or minus the square root of 1/3. Rationalizing, we have the tangent of theta equals plus or minus, and I multiply by square root of 3 over square root of 3. And I have the square root of 3 divided by the square root of 9, which is 3. So at this point, I have isolated my tangent of theta. So now I can start to find theta. Okay, so we see plus or minus right here. That's a good place to start. And think about, where is tangent positive and negative? What quadrants am I going to have to work in? Well, tangent is positive here and also here, so I should have angles in both of these. But I also want to know where tangent's negative. Well, tangent's negative in the second and the fourth. So I'm going to have 4 angles that fall between 0 and 360 that satisfy this. So now I need to ask myself, do I know when the tangent of theta equals square root of 3 over 3? What angle has that ratio of square root of 3 over 3? Well, thinking through, I know that the tangent of theta equals square root of 3 over 3 if theta is equal to 30 degrees. Well, there's 30 degrees right here. Falls in the first quadrant. I found my first angle. Because that was when it was a positive square root of 3 over 3. The other place where it was positive is in this quadrant down here. So if I take and I rotate around into the third quadrant, and I go 30 degrees beyond into the third quadrant, then theta is this length, for this rotation. So it's 180 degrees plus another 30, so 210 degrees. So I also have an angle of 210 degrees. That will give me a ratio of square root of 3 over 3. The other two quadrants are where it's negative. Here and here. I'm going to use my reference angle, and I'm going to rotate into the second quadrant. I'm going to stop short of 180 degrees by 30, and so this angle is 180 minus the 30 degrees of my reference angle, so theta is equal to 150 degrees. If I use the tangent of 150 degrees, I'll get a negative square root of 3 over 3, but that satisfies. And then the last one, we could fall in the fourth quadrant. Again, I come into the fourth quadrant, I stop so that I will have a reference angle of 30 degrees. And how many degrees does it take to rotate around here and stop? So I have 30 degrees remaining. And that would be 330. I have 4 solutions, 4 values of theta that will make it true. Take time to check. Right now I'm not going to take the time to check, but plug them back into the original and make sure that when you evaluate, it does balance, that it does come out equal to 0.